So, welcome to our second experiment. In this experiment, we want to figure out a little bit more about what a compound has, or what a homogeneous solution has, more than it just having protein, right? Because as you know, there's 20 amino acids, and they all have big influence on the behavior of that protein once it's in its polymer form. So for this experiment, you have 3 known amino acids and 1 kind of unknown amino acid. It has a name. In your lab manual, you'll see that it's named casein hydrolysate, but we don't know what casein hydrolysate is made up of. We know it's made up of more than 1 amino acid. So we have chromatography paper, we have our 3 known amino acids here in these beakers, and then we have our unknown amino acid, our casein hydrolysate. And what we're going to do today is take a chromatography strip. I've blown it up on the board here for illustration, and we're going to put spots of our known amino acids at the bottom of the paper, all at the same line, and at the same starting position we'll put our unknown amino acid. So this one. Okay, so to illustrate how to deduce what is making up our unknown amino acid, which we're calling D, or casein hydrolysate, let's illustrate how these amino acids will go up our chromatography paper. Right? So amino acid A, we do know what it is. It's going to be arginine. So I'll write the word here. Arginine. And give it a red star. B is glutamic acid. Get a blue circle. C is tyrosine, which I'll give a box. Now you see these RFs that I have here. This is what we're measuring on the chromatography. So we're measuring the distance traveled by the spot over the distance traveled by the solvent front. So for something that maybe is really tiny, like arginine, I believe, we would expect it to travel up the sheet faster than our larger molecules. So I'll put a star here at the end of our experiment. Something that was middle in size would maybe be like here by the end of our experiment time. And then we'll say that C is really a larger molecule, larger amino acid. So it's down here. When you compare that to your unknown, right, if you see that it has a dot here, and it's also got some dots at the top, you know that it had amino acids that were this size, and it also had amino acids that were this size. But it didn't have any amino acids that were in the middle. So the kind of, instead of looking to see if they're on the same line, we're going to measure the distance traveled here. That will be our numerator, distance traveled by the spot, and then the distance traveled by the actual solution that we're running it all in. I ran out of colors, but I'll put it in black here. So we are assuming that this will be about where our solvent gets, but you'll see on the video we might not. We might end it in the middle of the chromatography sheet. It doesn't matter as long as we are comparing the ratio of this distance to the ratio of this distance. And do the same for this one, compared to this distance, and and then this one here. All right, let's actually do it.
Cool.
Okay, so here are our chromatography strips. I have 2 for good measure. It's always good to have replicates when you're doing an experiment. And I have a ruler here because I want to put my dots about 3/4 of an inch away from the bottom of the chromatography strip. So here's our inch mark. So 3/4 is about here. That seems really high up, honestly, but this is where we'll start. And I'm going to put 4 dots, 1 dot corresponding to each of our amino acids. So this will be 1 dot, 2 dots, 3 dots, 4. And over here I'll make them even better spaced. 2. And this is marking where I'm going to put my starting amino acid drop. They still have to travel up the paper. Okay, so there's the dots. Okay, so now I am dipping my capillary tube into my arginine beaker. It picks up a bit of solution due to that wonderful capillary action we talked about. And I'm dropping arginine on spot A on both sheets. Wunderbar. Here comes amino acid 2, B as in boy, which is glutamic acid. Yeah, just want to double check. Here comes B. And next up is tyrosine. And lastly, our mystery amino acid, otherwise known as casein, hydrosylate. Capillaries are the best. And now we're ready for Slovin.
Action.
All right, so you'll see that we
Oh, wait, sorry.
Okay, so you'll see that we're at the hood, and that's because we are working with some chemicals that you don't want to inhale into your lungs. This has a negative pressure. So I have my developing jar here. I'm going to drop our chromatography strips into it, and then we're going to let them do their thing. Here's our amino acid chromatography strips from before, and these are ready to come out. And so I'm going to pull these out with the tweezers, and I'm going to dry them now. Ooh, some of it. I'm going to dry these now over here on our heat rack. So. Okay, so we'll let those dry completely. Okay, welcome back to the hood. We are about to spray menhydrin onto our dried amino acid strips, which are here on our heat block. So I will just move these a little bit closer. And again, we're using the hood because we don't want to inhale menhydrin at all. to spray liberally on our test strip. And then we're going to let this dry again, and it should show. After it dries, we should be able to see our amino acid compounds. Alright.
Good.